Good morning, friends. In the last lecture, we talk about the transmutation reaction by the alpha particle. Today, we are going to continue this part. We have to talk about the transmutation by the proton. What is a transmutation that we have seen? It is nothing but a conversion of the one nuclei into the another nuclei. First example we have seen with the alpha particle. Like the alpha particle, we have to talk about the proton. Okay, please go through the last lecture. We have seen the some terms also. What is a projectile, what is a target, what is a recoil nucleation, what is a ejected particles. That all terms we have seen in the last lecture. Along with the we have talked about the transmutation by the alpha particles. Today we are going to continue with the next part, that is the transmutation by the proton. Like the alpha particles, proton also carry charge and hence will experience an energy barrier for this particular entry into the nucleus. Here are the example. In this particular proton is there are the four sub reaction that we have to see. That is a proton neutron PN type reaction, P alpha type reaction, uh, PN type reaction, P gamma type reaction, P alpha type reaction, and PD type reaction. D is nothing but a deuteron. First of all, we will talk about the PN type of the reaction. The PN type of the reaction can occur with the proton of energy greater than or equal to 20 mega electron volt. Here you can see the sodium is there on which we are going to bombard the proton. It will emit the neutron. Neutron is having the atomic number, that is a particular 0, mass number 1. Okay. It will gives you the product, that is Mg. Correct this thing, because when this add by the one, sodium magnesium will be there. Discard this sodium, there will be the magnesium having the atomic number 20, that are 12 Mg, 23 plus 0 and 1 will be there. Then P alpha gamma type reaction for a number of lighter radioactive isotopes. The radioactive capture of the proton takes place. Here aluminum will capture the proton and it will give you the gamma radiations, which are the chargeless and massless. That is, if you add 1 will be added over here, then the silicon will be there. 14 atomic number is silicon, 14 aside 28 will be there. Then next reaction is a P alpha type. Alpha is nothing but a helium will be emitted, proton is bombarded, helium is emitted. 7 that is 3 Li7 is there plus 1H1. It will give you the formation of 2 He2 4. Another example is also given. 7 N14 plus 1H1, that will give you the 8. That will give you. Now what we have to remove? We have to remove that 2 He4. Means 2 will go. 7 plus 1 8. 2 will go. We have to sum it. 7 plus 1 8. 8 minus 2, that is a 6. 6 is nothing but a carbon. That's why the 6 11 will be the product. How we can do this? You know this is a 12 minus 0. 12 will be there, and here it will be the magnesium. Instead of the sodium, there should be the magnesium. Please note it well. Then P alpha type reaction, in that we have seen that there should be the loss of the alpha particle. Alpha particle is nothing but 2He4. Means it is in the form of the helium, same as the helium. Okay, means what will be there, that is a 7 and 14. This example is again the simple, first one is also simple. Plus 1h1, it will gives you 7 plus 1 8, 8 minus 2. Why 2 I am minusing? Because alpha particle is ejected. Alpha particle is ejected, and that's why 12 that 8 minus 2, that is a 6. 6 is atomic number of the carbon. That's why you will get the carbon as a new daughter element. Then PD type reaction. D is nothing but a deuterium. Deuterium is nothing but a 1h2. Atomic mass is the different one. If you are taking the barium, that is a beryllium, B 4 4B is 9 is there, plus 1h1. When you bombard, C 4 plus 1 5. Okay, deuterium is emitted there, means 5 minus 1 4. 4 is nothing but the beryllium. Okay, then 9 plus 1 10. 10 minus 2 8. That is the beryllium. It will be there with the different isotope. Their isotope will be there. Then the transmutation by the deuterions. The binding energy for the proton and a neutron in the deuterium is low. Therefore, it can be considered as the loose combination of the protons and the neutrons. Three different types we have to see: deuterium proton, deuterium neutron, and the deuterium alpha type. What will happen when you bombard the deuterium? Proton will be emitted. Means 1h2 you are bombarding and you are getting the 1h1. First of all, you have to write this 1h1. 3 Li 7 is there, plus 1h2 is there. 3 1 plus 4, 4 minus 1 3. This is the Li. You will get a different isotope of the Li, lithium. Same way you can apply it for the carbon. Cadmium is there, 48 114 plus 1h2. It will give you the 48. Same cadmium will be there with the different isotope along with the loss of the proton. DN type of the reaction, large number of the DN type of the reaction are also known. This reaction can compete with DP type of the reaction for the given pair of target nucleus and the projectile. See, when two deuterium 1h2 1h2 or say 1d2 1d2 when react, it will gives you the loss of the proton and that loss of the neutron 0 and 1. Okay, 1 plus 1 2, 2 will nothing but a He. Okay, then 2 plus 2 will be the 4, 4 minus 1 will be the 3, that is the 2 He, 3 will be the example. You can take the another deuterium along with the deuterium. It will give the formation of the helium along with the neutron. Then D alpha type of the reaction. You know alpha is nothing but a helium atom will be lost. 3 Li 6 plus 1h2 is there. You can take the different example also, and different example will be there in the exam also. Okay. The alpha type means you are bombarding the deuterium and you are getting the alpha as a reject type particle. First of all, you have to write this deuterium along with, on the right side you have to show the loss of that particular alpha particle, that is a twice He. Then you can easily write down the product whatever is required. Then transmutation by the neutrons. Neutrons are the best projectiles that can be used in nuclear transmutation reaction. Nuclear transmutation reaction. Neutrons are electrically neutral particles, therefore they have no energy barriers to face the target element, can easily capture neutron. I think so. You are getting this part. That's why I'm going ahead and ahead. Okay. You got this particular whatever the reaction you have seen. Then the last transportation by the neutrons. We can use neutron also. There are the NP type of the reaction. NP type means we are going to bombard the neutron and the loss of the proton will be there. 0 N1 will give you the 1H1. Then the example is the aluminum 1327 plus 0 N1 is there. Okay, there should be the loss of the proton should be there, and proton once lost, that is 1H1. Okay, means 13 minus 1, 12 will be there, 12 mg, 27 will be there. Then next, N gamma type is there, N alpha type is there, N 2N type is there. These different reactions are there. In gamma type, there is no charge and no mass loss if the gamma is there. 29 Cu63 plus 0 N1, it will give you the 29 Cu64 plus gamma. Then in alpha type reaction, 3 Li6 plus 0 N1, it will gives you loss of the 2 He4. Okay, 2 He4 will be there, left thing will be the 1H3, that is nothing but the tritium will be there, tritium will be there. Then the another example is there, 5B10, that is the boron is there plus 0 N1. When there will be the loss of the alpha particle, that is a 2 from this atomic number, we have to minus 3 will be the Li, 10 plus 1, 11, 11 minus 2, that will be the 9. That is a 4 we have to subtract, that is a 7. 3 Li 7 will be there. N2N means 1 neutron is bombarded, 2 neutron will be ejected. At that time, C6C12 plus 0 N1, that will gives you the 2 0 N1 pack, means atomic number will be minus 6 minus, that is 6 will be the same carbon. 12 plus 1 13 minus 2, that is 11. 6 11 will be the new nucleus you will obtain after this reaction. Very simple reaction that you have to remember. If you are not getting this reaction, I can explain it again, but please go through this reaction well. If you have any problem, any doubt, you can freely ask on the WhatsApp group, or say at any way you can ask whatever the difficulty is there to you. Okay, please go through this reaction. First is the transmutation by alpha particle, transmutation by the proton, transmutation by the deuterium, and transmutation by the neutron. These 4 major types that we have seen, under which we have seen the different example. Please prepare it well. If you are unable to understand, then you can ask freely. Okay, I will try my level best to explain you again this concept, but it is a very easy and a very simple concept. Please prepare it well. If you are not getting any point, you can ask that on the WhatsApp group, or say that Google Classroom. Okay, please daily go through this lecture, then and then only your concept will get clear. These are the few reactions that we have seen under this part, and today we will stop here. The remaining part we will see in the next lecture.